Hi guys, so in this video I will do a breakdown of how I did the slime generator, how I created vertex colors, and every parameter from this HDA interface. And if you're interested about creating the slime generator from scratch, I have a Patreon video available. So starting from the bottom, I have a tab about materials. So basically what it does is that I can drag and drop materials or material instances directly inside Unreal Engine, and HDA will process it and it will assign corresponding materials to corresponding part of the mesh. So this is, I can assign material to the light bulb, or I hope I pronounce it correctly, what to this part, and pretty much to every other part of the object. Next is top shape settings. This is this one. I can control the length. Oops. Radius, and also this metal things. I'm not sure how they're called. They also scales accordingly to the shape, to the radius of the top part. Thickness, and I can apply a custom ramp to make it more unique. It's by the way, it's using a sweep node, but I will show you in any case. This is this metal parts. And this is ring settings. I can control the length of this tube shape, as well as the radius, and also do a custom ramp. And so the bottom part, I can choose between two shapes right now, but I can add more in the future. So I can choose flex with the planks or whatever it's called. I can change the radius, number of columns. I can control the shape of it using custom ramp. And I can also do a bending, which will be applied to all of the shape. I can also do a scaling operation like so. This is all done by the bend SOP. I can generate UVs. UVs, I'm not sure, I don't think it's actually good UVs, but it could be better. But UV part of every model I have made, I'm still exploring how to make it even better, because right now it's basically auto-generating UVs using labs auto UV without any like logic. It just unwraps whatever I put into it, and yeah, I can generate Lowpoly mesh out of it. I can enable coloring, and the coloring is, I'll show you. So let's actually switch to the different view. And disable group, because group will show this orange color. So when I click enable coloring, this is exactly a vertex coloring. I can color three parts of the mesh: top part, mid parts, so everything in the middle, and bottom part, which is this bottom shape. So I can add ambient occlusion coloring. I can remap ambient occlusion. I can change the color of ambient occlusion. Let it be something like that in this example. I can also change choose operation, which is like in Photoshop. I can change the base color of the shape. I mean bottom shape. I can also add the color noise. And here is a quick showcase of what it does. I can change the noise type, offset it. And as you can see, ambient occlusion coloring is still there because I'm multiplying this color noise on top of ambient occlusion noise. And I can do a lot of other things, which like change the hue of the color and much other dirt buildup. Something like that. Oops. So yeah, something like that. So and top part can be also colored in the same way. So all of this has been used by the Attribute Adjust Color, which we'll show you in a couple of minutes. Which in this case, all of the data is stored in the points, not vertices. But in any case, this is vertex coloring, as far as I understand it. And so yeah, this is about coloring part. And it can also generate Substance Painter material IDs. This material IDs has been created using labs quick material by specifying a specific color. And this is how they are done. So you can export as an FBX and Substance Painter will recognize this material. But for some reason, it doesn't recognize this material name. So this is something I'm not sure about right now. So keep it in mind. So yeah, this is what parameters this HD have. And let me actually show you how it's created. So this is the whole node graph. Bottom part, this contains from the rounded part and this wooden planks, and this middle part is like light bulb, metal framing and stuff like that. And this is the top part. So the bottom part was created from the line. So you create a line, it's a basic line, I mean default line, nothing has been changed here. Then I'm doing a resample. I just changed the maximum length to 0, 0, 1, and this is because I need more points to create a custom profile using next node. And the next node is a sweep node, which indeed creates the shape using this profile, or using this ramp. And if I don't have enough points, the mesh will be like this kind of jagged. But if I provide enough points, I can create a more precise shape and more complex shape. So under the sweep node, I have changed the surface type to round cube. By default, it was like so. And I have exposed these parameters to the HDA level. And by the way, I will be explaining how to do it. And I will link videos about explaining how to create HDA parameters. So everything here is by default. The only thing I have changed is I checked this apply scale along curve option because I want to create a custom shape using this curve. And then I'm using a polyfill. And the reason I'm using it is because I want to close this bottom and top holes. And the way I have did it is by changing the fill mode from the single from this option to triangle fan, and disabled the deform patch, and also exported the patch group which I'll be using in the polybevel node here. And so this is what polybevel node does. It just bevels bottom and top edges slightly. So the way I have done it is by copying parameter and pasting relative reference. This is because if I decided to change this group name, I don't need to worry about changing group name here also, because it will, without a channel reference, this will throw an error because of not matching group names. So I can change it like so. So as you can see, this is a group name and polybevel still works as expected. And under the polybevel node, I have checked this ignore flat edges, because by default it was beveling. Should show you at the bottom, because by default it also beveling those edges, and I don't need that. And on the slide on the ring edge, I have changed it to always, and under the collision and limits stop loops, I have changed it to simultaneously. And this is to detect collision geometry, edges in this case, so it won't go any further when it hits a certain edge. In this case, when it detects this edge, it won't do more beveling, if it makes sense. But if I change it to some individually, oops, it will go like so. But in general, it can provide a bad topology. And not the good looking geometry. So yeah, and then I'm creating a point jitter node. This is to add some stylization type of look. With you need to make sure you have a very small value here, because it can go crazy like that. And the seed is to get random result by state. And here I have a switch SOP node to disable or enable stylized look. This has been done with the toggle under the HDA level. Oh, actually, I haven't used it. I have disabled it. Sorry. So never mind. I have deleted it from the HD level. So my bad. And this is how I done the bottom shape. And creating planks like shape is fairly easy also. So it starts with a simple box with 4x4x4 division, axis divisions, which is the default one, I guess. Oh, I have changed it to polygon mesh. This is because this is why it's by default. And then I resize it to make it like a wooden leg, some sort of it. And I don't also used this. And then I'm rotating it by -90 degrees. I'm clipping the bottom here using the clip SOP, just to add some angle to the leg. And then I'm also doing a polyfill to close this hole. And then I'm doing a polybevel with also including with also a checkbox to ignore flat edges, because by default it was like so, and I only need to bevel outside edges of the leg. And then I'm creating an angle of the stand, and then I'm copying it using copy and transform SOP. And you can play around with it. Could be like so. Could be like so. So you can play around with it. And you can also play around with the angle. It can also be some sort of HD parameter to control. And then I'm using a remesh grid, which is VDB basically, to combine those meshes instead of using Boolean. And here's my settings. Adaptivity is to remove certain faces to make it more low poly. I would actually prefer to use Boolean instead of remesh grid or VDB basically in this case, because of these jagged edges, which I don't really like, and I will most likely will revisit this in the future to make it a Boolean shape instead of creating VDBs. And so yeah, this is how this like shape was done. And then I'm basically switching between two shapes using switch SOP. And this is what this control does. And then I'm creating auto UVs for this using an unwrap method and island rotation to like 100 degrees. And also switch node to generated not generate UVs. And this is mostly for like fast iterations. So so that I have an option to enable to generate UVs once I have created a final model, final version of the model. So UVs doesn't need to be generated every time I have changed something on the mesh itself. So what I mean by that is when I change these parameters, UVs won't be updated as it would with this checkbox enabled, and it kind of slows down everything quite a bit. So I hope it makes sense. And then I'm using another switch node to generate substance material ID or not. Everything here is by default except for the color and the material name. And after that, the coloring part. I will come back at the end of the video after explaining how I model it, everything. So I'm here also creating a switch node to enable disable coloring, and then I'm creating the Unreal Material node, this one. Everything here is by default. And the only thing I have exposed here to the HDA level is the string parameter, which you can see here. So copy parameter and place relative reference. And that's pretty much it for the bottom part. And let me actually show you how the middle part was created, which is this part. So this is a kind of a metal frame. And this one is where the light bulb will be placed. So let's start with the middle, with this part. It also starts with a simple line with 12 points. You can control it. And then I'm doing a bending. I will show you why I'm doing bending when it's like combined together. Then I'm doing a sweep to create the shape. I'm also adding a single polygon on the end of the sweep. So by default, it doesn't have any end caps, but providing with a single polygon, it can be like so also. Then I'm creating UVs for this. Instead of creating auto UVs, I can create UVs directly inside sweep node. But I decided to do this way, which I will, as I said, this is not ideal, as this is something I will be revisiting later. And then I have a circle, a simple circle, which with a uniform scale controlled by the radius of the let me actually see, of the middle tube, which is this one in the middle. So this is to make sure that this part aligns perfectly here, instead of being like inside of this geometry or outside this geometry. So it is a sweep node here in this middle shape. I'm copying this parameter and pasting the relative reference here. So let me show you. If I change the radius of this middle tube, the placement of this side metal things will also be changed, because the radius of this tube has been changed and the circle radius has also been changed. So, as you can see here. So this is why I have used a chain reference here. And you can control the number of frame of this metal frame, so whatever it's called. And this comes from the circle itself. So because this tube is being copied onto the circle points on each of the circle point, this one, this one, this one, and so on, to every single point. As you can see here. So this is a point, this is a point, and so on. And the only thing to keep in mind here is I have changed the normal direction. By default it was like so, and I have created a normal direction on the circle itself to be pointing outwards instead of down. But you can also do it in different ways. I have decided to use a simple Vex expression. So you create a normal and you set the normal attribute which will be equal to the point position of the circle. Not sure how to explain it properly, but this is how I done it. And then I'm adding a match size SOP. And the reason I have used it is because I want to place this like metal tubes onto the top portion of this middle tube. So what I mean by this is this. And match size provides an option to place certain objects onto the top, onto the bottom, onto the certain side, and so on and so forth. And you can play around with it. And I have changed the justify y to min and max to max. And if I want to change to place this tubes onto the bottom, I can swap those values like so. So the placement of this frame tubes will be always on the bottom of this middle tube. But in my case, I need to be on top. And I also offset it a little bit because it copies this geometry onto the top of the bounding box of this tube shape, and I didn't need that. I need it to be like somewhere here. So this is the reason I have offset it a little bit. And then I'm creating a substance material. And after that, I'm creating an Unreal material here, the same way as I did with the bottom shape. And this switch is for creating colors as a shape. So I can change the color. And this is a vertex coloring here. This is a simple one. And also one thing I forgot to explain about is this expression on the line length, which is this one. It's kind of a long one. And what this expression does is that it multiplies bottom taper value by the sweep radius value, and then doing a multiplication and additional if statement, a channel parameter if statement. It checks if the bottom squish value is bigger than 1, and this ampersand symbol stands for AND operation, and it also checks if the bottom taper squish pivot is also bigger than 1.5. Then, if this is true, it will multiply this taper and sweep radius by bottom taper squish and bottom taper squish pivot value. Otherwise, if this is not the case, and so if the value here will be 0.9 and here 0.4, whatever, then it will multiply by this value, which is kind of hard-coded value in this case. So as you can see here, I basically explained the same thing. And and why it's actually needed. Let me show you. Like here, for example. So for example, when I change the radius, this will be a sweep radius. Which is this one. This radius of the top shape. So so this radius drives the length of this middle shape. And on top of that, if I also want to add a taper, like this tapering here, so it's not a straight lamp like so, like a cylinder or whatever. It also will multiply by this tapering value, which is it will only multiply by the bottom taper, which is this one. So like so. As you can see, it's also increasing the length. But it might break up at some point, which I haven't fixed yet, because as you can see here, it will break apart a little bit. But could be kind of intentional look, but so yeah, keep in mind. And also, it will also multiply additional values if this squish and squish pivot is bigger than 1 or 0.5. So if I want to add 0.5 and a squish pivot, as you can see, it's also changing the value. And why 0.5 actually is because when the value of squish pivot will be bigger than 0.5, this will mean that squishing will be happening somewhere in this area of the top part. But when the value is lower than 0.5, the squishing will be happening like here somewhere. So that's the reason. But I haven't actually. It's not working 100% correctly. I have missed something, so this is something that could be improved here. But yeah, that's the general logic applied here. And what about the middle tube? It's a simple line again, resampling it, sweeping it, creating a quick shade material for the substance material ID, sorry. Then creating auto UVs. Also using attribute adjust color for the coloring. Then creating unreal material. After that, I'm creating a light bulb placement, the same way as I did the bottom shape. I'm also creating a line, but instead of resampling it, I'm creating 20 points directly on the line SOP here. Then I'm sweeping it using custom profile shape here. Then I'm poly extruding it, which is basically a thickness. And I can also output back here, which I forgot to do. Then material ID, color ID, vertex color, painting and creating a real material here, placing this part on top of the middle tube here, which is this one, also using a match size. And the middle tube has been plugged into the second input of the match size, which is the bounding box of the collision geometry to match, as you can see here, because without it, it will be like so. And then also using a min and max options on the justify y axis. And to create a light bulb, I have used a simple sphere. I squashed it a little bit by playing around with the radius. And that's pretty much it for the light bulb. UVs, Vertex coloring, Unreal Material, and here's the middle part group, which I will use later. And if I group everything together, this is how it looks like. And after that, I'm placing everything on top of the bottom part, which I'm merging here. So this part, I'm merging it with this middle parts. And the way I have done it is also by using a match size SOP. And on the second input is the bottom part of the lamp, which is this one. I'm also using justify y min and max, and then merging everything together, because without merging it will be like so. And the same goes for the top part. And what about the top part of the lamp? The main shape starts with the line. I'm doing also a sample, using sweep to sweep the line, creating end caps using a single polygon, and as well as exporting the end caps group, which I will be using in this blast SOP here. And also using the apply along scale, and also using apply scale along the curve option to create the custom shape here. Blasting end caps here by copy parameter, which should be done by ideally by pasting relative reference here, because if I desire to change this type of group, this blast node won't break apart, because without using a channel reference, this won't work, because the group name has been changed here. But with channel reference, this will work. So I'm blasting end caps here, provided by the sweep node. And the reason I need it is because I need to create thickness for the bottom, or for the top part of the shape, which is this part. And then I'm creating UVs for it, substance material, coloring it, creating Unreal Material. And this switch is for creating an edge ring here and here. And the way I have done it is by also blasting end caps. And by the way, the reason I need to blast end caps is because if I don't do it, this is what the result I get. So, but without it, this is the result. Because top part of the lamp is actually doesn't have any closed holes or whatever it's called. So this is the reason it's deleted. So the edge ring is done the same way, by blasting the end caps here, adding thickness, creating auto UVs, substance material, coloring, Unreal Material. And basically it's the same thing as here. The only difference here is that I'm extruding top parts of the tube and on the bottom, but everything from this part is the same as here, as in this part. It's identical pretty much. The only difference is here. So here I'm blasting side group. I'm using a group by the end caps here under the poly extrude. Then I'm deleting side group from the poly extrude, copy parameter, and paste relative reference. Like so. And then I'm creating thickness, and then I'm creating a bevel. And then I'm fusing everything together, creating UVs, substance material, vertex coloring, and unreal material. And this is the result. And then I can switch between top shape with or without edge rings, or whatever it's called. And after that, I'm creating a top and bottom tapering using band SOP. So I have disabled everything except of the taper. And I also forget to use a bounding box expression to make sure the bounding box is not bounding box, but the capture length will be equal to the bounding box size on the y-axis of the input geometry, which means is 0 is the input geometry from this input here on the node, and it will basically capture the entire length of this top shape, because by default, as you saw, this line was capturing a larger length than it should have. So yeah, and the same goes for the bottom part here. I actually need to do the same thing, like so. Like so. So if I change the length of the tube, or in this case a line, the length will be also changed here accordingly. I think I actually need to do the same thing here. Yeah, so under the capture origin, I have also used the bounding box expression to move the capture origin of the band SOP in the right place. The same thing could be done here. Oh, no, not really. I guess it's somewhat related to the negative y direction. I'm not really sure. So yeah. And this is how the top portion of the lamp was done. And after that, I'm placing top part of the lamp. And after that, I'm placing top part of the lamp, again, using the match size SOP. But here, under the geometry I want to resize is this geometry. And where I want to place it is this part of the geometry. So I'm using the match size of this geometry. So it is where it's located, and I'm also using a min and max, and also offsetting it a little bit, because by default it was like so, on top of the bounding box of this middle part of the lamp, and I offset it a little bit down, and then I'm merging everything together. and then I'm blasting middle part only. And then I'm using a mesh size also to place a light bulb here onto the top of the this part. So this light bulb. To here. And also you can play with offset a little bit. And then again merging everything together. And then doing a UV layout. It right now shows an error because under the HDA properties parameters, I haven't checked compute UVs. And when I checked this option, it won't give any warnings here. So another switch to either generate or don't generate UVs. And then this is a global, I call it stylized look, which uses a band SOP. Again, I'm using a bounding box expression here to capture the entire length of this lamp, because by default it will be a 1, which is very small length, which doesn't capture the entire length of the lamp. And here I'm using a length scale options, tapering, band, and you just need to play around with it. Then I'm scaling it down, because I have placed a referenced human body here, and it was just too large in comparison to the reference. And then I'm placing it on top of the origin, just in case it will move somewhere. Then I'm creating a Lowpoly out of it, and preserve quads option is turned on here. And again, the switch to enable disable Lowpoly. And here I'm deleting pretty much everything from these attributes, and keeping only Unreal Material, UVs, or Shop Material Path and Material Override, which comes from this lab's quick material node, which is a substance material ID. Then I'm creating normals, creating a group collision node, and I have named it as a rendered collision geo, which Houdini engine and Unreal Engine will recognize as a collision geometry. And I have created a basic preset for it to quickly paste it here. And you can create a preset by creating certain, by checking certain options and then using a save preset option, and you can call it however you want. And that's pretty much it for the lamp. And let me quickly show you how I created the vertex coloring. So I have converted vertex coloring inside of separate HDA. This is a whole node graph for coloring. This is the coloring path itself. This is more a stylization look. And the reason stylized coloring HDA has stylization look is because in the future I want to have an input geometry and stylize it in a way like bending, point jitter, or whatever it might be also. So this is the reason I have these options here. So here I have quite a few switch nodes. And it basically provides another type of variance look. We can do bending here, remeshing it, which can also produce as a like this kind of look. It can also do an edge damage to the shape, but in terms of lamp, it's not really suitable. It can also do a point jitter, like so. And the match size to place it onto the top of the world origin is needed because if the ground plane will be used, and the reason ground plane is used here is because of this physical ambient occlusion node. So here I can control the ambient occlusion level, and I can also preview a ground plane which casts shadows onto the bottom of the surface, because without it, without a ground plane, the effect won't be the same. It will be like so, which is not what I wanted. So the way I have did it is by creating a ground plane, and then I grouped it. And the reason I grouped it is because I want to delete it later, because it's a temporary ground plane, which only used by this ambient occlusion SOP. So after computing the ambient occlusion and storing it into the AO mask parameter, I'm blasting it away because I don't need it. And then I'm using this data from the physical ambient occlusion by labs node. And under the attribute adjust color, I'm using a pattern type to remap attribute. And under the remap attribute, I'm sourcing an attribute which is AO mask, and I'm copying parameter based on relative reference here. And now I can do whatever I want here with this mask provided by the ambient occlusion node here. And I expose these parameters to the upper HDA level. So, and before ambient occlusion, I'm providing a base color. After that, I'm blasting ground plane also here, and using a switch SOP to enable disable ambient occlusion. Then the same node from labs physical ambient occlusion to create mask for X and create mask for valleys, which is basically for curvature. And the same procedure goes inside every single attribute adjust color here. So I'm taking the output attribute from the lab's physical ambient occlusion and pasting it relative reference here. And the reason I have used the physical ambient occlusion by labs is because instead of like thickness, labs calculate thickness, is because I have read on ArtStation, on labs, on SideFX Labs ArtStation page that this physical ambient occlusion node has updated algorithms for computing AO, curvature, and additional things like dirt buildup. So it's updated versions of previously created nodes like labs thickness, calculate thickness, and other nodes. So yeah, and additionally, I have used labs edge color node here, which also uses a blend mode here. And by the way, about the blend mode, every single attribute color adjust, except the first one, is using a multiplication operation here to multiply every new color that has been added onto the base color, which is kind of in the Photoshop manner. And under the base color, I have set an operation to set initial, like initial color. And I'm not sure what to tell you about these values. You just have to play around with them, and that's pretty much it. And the same for valleys, and the same for dirt buildup. I'm remapping every single mask here, and also remapping it on the attribute color adjust here. And then I'm using a global noise pattern, which is set to pattern type to noise, and exposed every single option here. And in the end, I have a global color correction here to control the hue and stuff like that. And then I'm computing normals, which is also done by switch SOP, and giving, and the output here, geo is here. And all of these parameters could be used inside Unreal Engine directly. And this vertex coloring could be combined with Unreal material inside of Unreal Engine by with this Unreal material created by Attribute Create. And the way it could be done And the way it could be useful is to create some sort of highlights or like metalness look or whatever it might be. So like minor Unreal material roughness, metal, and stuff like that could be applied here. Possibly a transparency or translucency. And hope it wasn't too confusing. And if it was confusing, please write a comment in the comment section. See you in the next video. Take care, have a great day, and have a lot of joy. See you.